For number 2, we have sine of 2x is equal to cosine x. And any time you see one of your trig functions with something other than just a variable like x or theta inside the parentheses, I want you to think that you're going to have to use some sort of formula to replace that so that we actually start working on this side of the equation. Alright, since this is sine of 2 times x, that's a double angle formula. So if you look at your Quality Core reference sheet, sine of 2x is equal to 2 sine x cosine x. So all we're doing is replacing that. We're just using substitution and replacing sine of 2x with the equivalent formula on the other side. Alright, so now we're in a similar situation to number 1 where we have things on both sides of the equation. So let's get it all to one side. So we're going to subtract over that cosine x. Okay, and I want to be very clear, when you look at this, it's kind of tempting to see, you see that cosine x minus cosine x to cancel them out, but you really can't do that. These are all grouped together through multiplication, so those are a group, those are a pair. They can't be split apart by that minus cosine at the end. So when you look at this, our whole goal for these is to factor them, and since they both have a cosine in common, we can go ahead and factor out a cosine. So we're left with 2 sine x minus 1. And then we can set each factor equal to 0. So we get cosine of x is equal to 0. 2 sine x minus 1 is equal to 0. The first one's already solved for. Cosine is 0. Over here with the sine, if you add 1 and divide by 2, you end up with sine of x equaling 1/2. Alright, so first we're going to look for where cosine is equal to 0. So if you look at your unit circle, cosine is equal to 0, so you're looking for our x-coordinate up at pi over 2. And cosine is also equal to 0 at 3 pi over 2. So those are going to be our two answers for the cosine side. So x is equal to pi over 2 and 3 pi over 2. Now we need to do the same thing and solve for y. Now we're looking for where sine is a positive 1/2. Right, so it's usually good. I usually like to think about, well, where that's going to end up. So we know that sine is always positive in the first quadrant, but then sine is also going to be positive in the second quadrant. So we're really just looking for the two angle measures in the first and second quadrant where the sine or the y coordinate is equal to 1/2. So if we go and look at our unit circle, sine is a positive 1/2 here at pi over 6. And I know that it's also going to occur at the other over 6 angle measure. If we look in the second quadrant, 5 pi over 6. So those 4 angle measures are going to make that equation true. Alright, so we had pi over 6 and 5 pi over 6. And if the directions just said to solve between 0 and 2 pi, so just one full revolution, those 4 answers would be our solutions. But again, it says give a general formula for all. So if we go back to our unit circle, we should be able to write it from there. Let's start with what cosine was. Cosine was 1/2, or pi over 2, and 3 pi over 2. And see how they make the same line? So we're going to keep the smaller angle, because it's only going to take us pi, or half of a circle, to get another angle. So pi over 2 plus pi times k. Then if we look at our other two angles, pi over 6 and then 5 pi over 6, you see those two do not create the same line on the unit circle. So in order to get another equivalent angle, we'd have to, from pi over 6, we'd have to go full 2 pi around the circle. And then same thing if you look at 5 pi over 6. From here, in order to get to another equivalent angle, we have to go all the way around 2 pi. So those 3 angle measures here are our final answer.
Made with Doodlecast Pro.